This is section 1.2, part B, special types of equations. A conditional equation is an equation that is sometimes true, sometimes false, depending on which values are substituted for the variable. A conditional linear equation has one solution. So everything we were seeing in 1.2 part A was conditional. An equation that does not have any solutions is called inconsistent, and an inconsistent equation has no solution. So the answer would be no solution. The type is inconsistent. Just like before, we didn't know what they were called, conditional. We didn't know they were called inconsistent, but we found they had one solution, such as like x equals 2 or whatever. The answer is going to be no solution to these kind of problems. The next type is called an identity. That's when an equation that is true for all possible values. An identity has all real numbers as solutions. Okay. There are two shorthand ways to write that. Instead of having to write all real numbers each time, you can do the set notation, which is a block R. It's a capital R with two bars behind it. Or you can do the interval notation, which is negative infinity to infinity. It's probably a little more common in this course to see the interval notation, although we can also use the block R notation. I'm going to try to use this one, negative infinity to infinity, to represent all real numbers. Okay. In example 4, we're going to try to identify which of these equations is conditional, inconsistent, or the identity. So I'm going to solve them just using my usual techniques by combining my variables and isolating the variable. So the first thing I want to do with these variables, I've got 3x minus 7x. I'm going to combine that to a negative 4x plus 2 equals, and then on this side I got 5x minus 9. Once again, I've got negative 4x plus 8. Right now you might be able to already tell that this equation is going to be interesting because you have the same number of x's on both sides. If I add 4x to both sides to attempt to get them on the same side, they eliminate completely. There are no x's left here and no x's left here, since negative 4 plus 4 in both cases turns to 0 x's. So you just have 2 equals 8. Okay. This is false, which leads to inconsistent. This is the type inconsistent. And since it is inconsistent or false, it means that the answer to this one is going to be no solution. Okay. Let's look at part B. I have a distribute to do in part B. So I'm going to start with 4 times 2 is 8. X minus 4 times 3 is 12. Equals 5 minus x. Okay, I've got variables here. So I want to get them the same side. We're going to add x to both sides. 8 plus 1 is 9. X minus 12 equals 5. I want to get the x by itself, so we're going to add 12 to both sides. So we're going to end up with 9x equals 17. And then we're going to divide by 9 to get x by itself. I was able to get an answer. The answer is 17/9. There is one answer, so this is the type conditional. And the answer itself is the value that I solved for x, the 17/9. Okay. And the last one, let's distribute. So when I distribute, I have 2x minus 10 minus x equals x minus 10. I'm going to combine the x's on the left-hand side to get them all together. 2x minus x is just x minus 10 equals x minus 10. And I want to subtract an x from both sides to get the x's both on the same side. Once again, kind of like this one before, you have the same number of x's, so you knew something was weird going on there. You're going to subtract, you're going to get no x's remaining, just negative 10 equals negative 10. This time it's an identity, meaning that you got the same thing on both sides, meaning that it's a true statement this time. So the answer is going to be all real numbers, or you can do the interval for that, negative infinity to infinity. Okay. Or if you prefer, you can write it in words, all real numbers. Okay. So in each of the two special cases, we had the two special cases and the one normal case. The answer itself is either no solution or all real numbers, and the type for those are inconsistent in identity. And the type for the one that has an answer is conditional. All right, and that is the end of part B.